Hi, welcome to another lecture on control. Today we're going to cover the introduction to using a microcontroller Arduino with MATLAB and Simulink. So you can see the contents of the lecture to the left. So I'll start off with an introduction. I'll then introduce you to two microcontrollers, the Arduino Uno and the Texas Instruments C2000. We'll then get started using the Arduino support package in Simulink, and then I'll run for you through an example, and we'll have some quick checking questions to make sure you're on track, and then a summary. So after today's lecture, I'd expect you to be able to explain the key features of a microcontroller, example the Arduino Uno, and also explain how to develop software using Simulink for embedding on a microcontroller. Okay, when we link that up to actuators and sensors. So you'll see on this slide, you have a microcontroller in the yellow square, where you've got a control algorithm within that. What you'll see as well is to the left, you've got sensors, so you've got a measured output being fed into the control algorithm, and then coming out of the control algorithm is the control output, which is being then the signal that then is the input to the actuator and of course the process. And then the system output is then measured by the sensor, and then you can see the loop. Okay, so if you can see then below that, what you've got is a microcontroller. So in this case, it's an Arduino Uno. This is digital. You can see this to the left, we've got a sensor. In this case, this is an ultrasonic sensor, so it's used to measure distance. This is a digital sensor. Sensors can be, though, analog and digital, or analog or digital. Analog to digital conversion and also digital to analog conversion. So ADC and DAC will be covered in future lectures. So in terms of the reference, we used to talk about a reference. This is kind of like what we desire in terms of the system to behave. So it could be, for example, temperature in a room, or in the case of using the ultrasonic sensor, it could be a desired separation distance or a distance to an object. That's defined within the control algorithm, and you'll see that more as we move on through the teaching, for the lectures. So yeah, as I said, the error is formed as usual, so it's the reference minus the actual output, or the measured output from the sensor. Okay, so you'll also see there to the right of the Arduino, you've got a motor. And within the weeks to come, we're not going to get to the point where we're getting a full feedback control system working this week, but as you follow from week to week, you'll see that we do so. So you can see on to the right, you've got a motor. Okay, so these three components you can create a feedback control system from, okay, for position control. So I've got a little example here just to show you how you can hook up the ultrasonic sensor, so for distance, with a motor. So you don't need to worry about the Simulink diagram below the video. But what I'll tell you is this Simulink diagram has effectively been used to generate the control system software, and then this has been embedded onto the microcontroller of the Arduino Uno board. So key things to look at, so you can see here, desired distance. So this is your reference. This is your desired separation distance. So what you'll notice when you're watching the video is when the distance is around 0.1 meters, the motor switches off, or I should say when it's approaching 0.1 meters, the speed of the motor reduces. Okay, because that's your reference, your desired distance. What you'll also notice here is you've got this block. This is the block that we're using for the ultrasonic sensor, and it effectively goes into the summing junction. One takeaways from the other, and then we form an error, and then the error multiplies by the PID block. And don't worry too much about this because we'll cover this in the coming weeks. And then here, pin 9 is your output. Okay, and that effectively goes to your motor. Okay, so the speed of the motor here is effectively determined based on the error that's formed. So the error that's formed through the difference between the desired distance and the measured distance. Okay, so that effectively changes the motor speed, as you can see as you're watching the video. So Simulink Arduino support package enables you to upload control algorithm to a controller using Simulink blocks. Okay, and then you effectively convert it to C code on the microcontroller board. There's the Arduino library in Simulink that I'll show you how to install in a couple of slides. And you can use effectively traditional blocks that you've been used to using so far. So if you look at that Simulink block, you can see kind of like things such as kind of game blocks, scopes, etc. And you can also update some of the parameters within the Simulink model in real time. So you can effectively change parameters and then see the effect that it has on the actual system in hardware. So moving on to now microcontrollers. So here I've got an Arduino Uno. The microcontroller is actually this board here that you can see labelled, this little chip that you can see labelled 1, and then that is embedded within the Arduino Uno board. The operating voltage is 3.3 volts or 5 volts that you can see here by 2. So you can see there, and you can effectively apply voltage to these little pins here. Alternatively though, what you can do is you can apply voltage to, well, you could apply voltage to pin 3, but alternatively what I tend to do is apply it to 4, where you can see here you've got a power jack, so an external power supply where you could, for example, maybe supply it with a 9-volt battery source, or 5, where you can see number 5, which is a USB plug, and you can power it directly off your PC. You'll also have to connect it to your PC when you're exporting your Simulink block diagram into C code on the microcontroller. So the exchange of that. So you'll have to have a USB cable. 6, so ID 6 is the digital input output pins. So there's 14 of them. Okay, and this effectively, when we looked at the previous slide, where we were having information coming in from the sensor, and then the controller then outputting information to the actuator. That's effectively where you kind of hook these up. So if you remember from the previous example, I'll show you a quick example at the very end to kind of make yourself a little bit more aware of exactly how we wire up inputs and outputs from actuators and sensors. 6 of these are pulse width modulation, PWM, and we'll cover that again in a little bit more detail in the next lecture. Digital ground, pin 7, analog reference pin 8. There's 9. ID 9 is analog input pins, and there's 6 of them. So what these are here is effectively if you're using a analog sensor, so for example a temperature sensor, which could be analog, you can effectively hook up your sensor here to bring the information into the microcontroller. Okay, so some operating properties. So the input voltage recommended 7 to 12 volts because you can get voltage drop on the board. Input voltage limits are 6 to 12 volts because the board has effectively a voltage regulator, so you can take it up to 20 volts and it will just lower the voltage for you. Current, the DC current, when you've got 5 volts and 3.3 volts, you can see it's 40 milliamps and 50 milliamps. Flash memory, so you've got 32 kilobytes. Don't worry too much about that. And then the clock speed is 16 megahertz. Okay, so it's a very fast board. But what you'll see as the weeks go on, I'll introduce you to the things such as computational delays. So you obviously can't, and the thing called sampling rate, again, I'm not going to talk too much about, and that they all kind of tie into this. So in terms of the board, the 6 analog pins, they are 10 bits. They have 10 bits of resolution. So effectively, what this means is you can map the input voltage between 0 and the operating voltage into the integral values between 0 and 1, 2, 3. Okay, so obviously, if you have a microcontroller with more bits, you get better resolution. And the pulse width modulation, which effectively enables us to apply a voltage between 0 and 5 volts to the DC motor that you saw previously. That is 8 bits, so that gives us effectively 255 different values. Okay, so 255 different values between 0 and 5 volts. So again, a controller with more bits will give you better resolution in terms of control and perhaps better control. So the Arduino is a great prototyping board, but if you wanted to move on to something that's a little bit more high spec and going to give you a little bit more performance, you might want to look at the Texas Instruments C2000. So if you click on this link, have a look at this in your own time, and you'll be able to see the board is the spec of the board, and it might be useful to compare that to the Arduino Uno for you to get familiar. So have a look at that link. So it's a high performance control board. So in terms of getting started, so installing the Arduino support package, effectively what you need to do is go into MATLAB, click on add-ons, and on the toolbar, and then go to Get Hardware Support Package. What you need to search for is the Simulink support package for Arduino hardware. Click on that, and then click on Install, and then follow the steps through. The steps through are quite self-explanatory, so I'm not going to go any further than this. And then once you've installed it, and it's on your computer, if you go to the Simulink library browser, so you'll have to go into Simulink, open up the library browser, and then within that, what you'll need to find is the Simulink package for Arduino hardware, and then click on that, and then you'll see you've got these sub-tabs, and then one that's useful to maybe look at initially is Common. And if you click on Common, you'll get something that looks like this. So again, you can start getting familiar with that, and you can see, for example, that you've got kind of pulse width modulation block, the one that we just used at the start, digital inputs, digital outputs, those sort of blocks. Okay, and we'll use them in the coming weeks, or the coming lectures, I should say. So in terms of an example, just to get you going, so what I'm going to show you is the on-off of an LED. So at the moment, obviously, we're not developing a control algorithm, it's just an algorithm that's just going to turn the LED on and off as we desire. So the exercise is largely taken from the link here, so you can see the link there, so you can get to that, and if you'd rather follow that than the video, then please do so. It's taken from MathWorks Help Center. So in this example, MATLAB version 219A has been used, and the setup is effectively an algorithm to turn the LED on and off, and what it's effectively doing is alternating 5 volts being applied and for a given time, and then not applied. Okay, and you can see the LED going on and off as a result. So in terms of the hardware, it looks like that. So you can see the Arduino Uno here. So from pin 9, power is supplied to the breadboard. And if you're not familiar with the breadboard, it's a device that is used to make simple electric connections in each of the columns. So if you can look at this one here and just look at the purple, you can see that each one of these columns is effectively, if you were to supply power to a given pin, the whole kind of column would also be powered. So the flow of power would be through that pin. Okay, there's like a divide in the middle in this one, obviously, and there's no connection between the top and the bottom. So in terms of this, so pin 9 is providing power, then that provides then to this whole, in this case, row of pins. Run it through the resistor, because what we need to do is reduce the voltage that's supplied to the LED, because the rating of this LED is, I believe it's 3.3 volts. Okay, so that reduces the voltage, and then here, then the circuit's complete, and then here we're feeding this back to the ground. Okay, so you can see a list there of the required hardware that you need if you want to undertake this exercise in your own time, and the steps are given here as I've just explained. Be aware that make sure when you're doing this example that you attach the long leg, the positive of the LED, to the resistor. Okay, so the long leg. If you got some resistors, you'll see that. So in terms of the software, so that was the hardware side that I just showed you. In terms of the software, we're going to use Simulink, as we said. So go into the Simulink, the Arduino support package that I showed you a few minutes ago, and what you'll need to do is drag a digital output pin. And if you double click on that, it might be by default that it says pin 9, but if it's not, double click on it and change the pin to 9. Because if you remember the hardware, we connected the power from pin 9 and then ran that through the LED. And then what we're going to do then is set up a pulse generator. So you'll find a pulse generator within Simulink in sources, and what you want to do is connect this to the digital output block. So in terms of the pulse generator, there's a new term that I introduced earlier. It's a sampling time. Okay, we're going to talk about that a little bit more in the next lecture. But sampling time, you can see here we've got we're putting an amplitude of 1 on the signal. The period, so the period is number of samples, so it's effectively 10 multiplied by 0.1, so it's 1. And then the pulse width is the number of samples, which is 5. So what this is effectively telling us is that the period is 10 seconds, and we're going to apply an amplitude of 1 for 5 of those samples. So effectively we're going to apply it for 0.15 seconds on, and then we're going to turn it off for 0.5 seconds. So what it's effectively doing is pin 9 is supplying a 5 voltages of power at pin 9 for 0.5 seconds, and then removing it for 0.5 seconds, and then that's effectively repeating. Okay, so that's that. We've also connected the scope. You can see here, if you remember in the original video, we had kind of an output that was showing you kind of like a repeated series of step inputs, and that is effectively where we got that information from. So it was using the scope. So if you do this in your own time, put the scope there, and you'll see effectively the pulse generator is just creating a series of unit step inputs. So configuring and running Simulink. So what you'll need to do for this is make sure your Arduino board is connected to the computer with USB, as I said earlier. Because what we're going to do now is transfer the Simulink diagram. Simulink's going to then convert that to C code and then place it onto the onto the microcontroller of the Arduino Uno board. So what you need to do when on your Simulink model, so the Simulink model you've just created, what you need to do is click Simulation in the top tab, Model Configuration Parameters to open the Configuration Parameters dialog. Then select the hardware implementation and make sure you select the Arduino Uno hardware, because that's what we're using. If you're using a different board, then make sure you select whatever board it is you're using. And then click OK. In your Simulink model, what you want to do, your simulation stop time, by default this will likely say 10. If you change that to INF, effectively infinity, what that'll mean is the series of step inputs been applied and removed will just continue. We'll just continue. Okay, and then the simulation mode, change this here to external, and then click run. Okay, and just be aware this is for MATLAB version 19A. If you use a different version, the steps, well, some of the newer versions, the steps at this point will be a little bit different. The model will now be deployed to the connected Arduino Uno, and what you will do is you'll get a report saying that your model's being built, and that's something we'll talk about a little bit more next week. And within there, you could have a look at the C++ code that's been updated. And what you'll notice if you then look at it, you'll see your LED attached to pin 9. The LED then should be blinking on and off, as you saw at the beginning of this video, the beginning of this lecture. So quick checking questions. So I want you to be able to explain the features of a given controller. So e.g. Arduino Uno. So stop the video at this point, give yourself 10 minutes, explain the attempt question 1 and also attempt question 2. So explain how would you go about setting up an Arduino Uno using Simulink combined with hardware. So I would advise for this initial question 2 is I would just use the example that I just showed you. Okay, the example that I went through at the start of the video is much more difficult. That's something that you'll be able to come to appreciate as you follow the lectures through. This week you obviously not can't understand that. So for question 2 I would relate it to turning the LED on and off. So linking up the hardware with the software. Further topics for you to explore, so it might be useful to look at key differences between Arduino Uno and the Texas Instrument microcontrollers. More specifically, maybe the Texas Instrument C2000. And also look into pulse width modulation, because I've spoken about that a little bit within this lecture. I'll talk about more next lecture. Might also be useful to look at sampling interval. Again, that will be covered within the next lecture. So give yourself 10 minutes, 10-15 minutes, or however long you need, pause the video and have a go at those quick check-in questions. So just a summary. So I hope that you've gone over the questions, quick checking questions, and you've understood. You've understood that you had an introduction to the workflow for embedded softwares on a microcontroller using Simulink, and you've been able to kind of get an idea for using the blocks for configuring, reading, and writing to Arduino components. For example, turning the LED on and off. And you can now use the run button and to configure and run a Simulink model to a supported Arduino board. So you kind of get the idea now that you don't need to be someone that programs. You just need to be someone that understands how to use the Simulink package. In this case, for the example this week, we've got an input, which is the pulse generator, and that's effectively applying an alternating voltage to pin 9. And you can convert that Simulink will convert that straight to C code for you. So you avoid the software part. So you've been shown kind of the hardware plus the software and how that leads to a product. So in terms of the key learning points, you should be able to explain the key features of a microcontroller, and you'll also hopefully be able to explain how to develop software using Simulink for embedding on a microcontroller. So I hope you've enjoyed the video and the lecture, and I look forward to kind of seeing you in the next lectures. Thank you.